Sometimes in game creation, we have to repeat the same task again and again for every asset we are creating: modeling, of mapping, texture painting, and so on. It can be tempting to try to automatize, at least partially, some of these tasks, especially when some assets are almost always the same ones. This recently happened to me WHILEWORKING on my adventure game, A Thief's Melody, when I tried to create film around every island in the game world. I quickly realized that it would be a time-consuming task, and I asked myself if I could find a faster way to deal with it. So I experimented with procedural texturing and automatic mapping in order to create a cartoonish form without too much effort on mapping. Thus, in this article, I will explain my thinking process and the different choices I have made to create the final form rendering in my game. Here, I use Unity as a game engine, Blender for modeling and texturing, and Krita to paint textures. My game takes place in an ocean-covered world, so having foam on the shores seems necessary. My biggest problem here is that my game is still being modified and island shapes may change and islands may appear. So, I want to find a way to create foam. It's not fast enough. Moreover, I may change the designs many times for a single island, and I do not want to have to recreate foam meshes from scratch every time. A while ago, some friends pointed to me the Rime VFX breakdown video by Fontmarty around PLA. There are many incredible tricks in this one. The foam in particular is very well crafted, and the effect is stunning. As long as you go fast, I like the rendering of colors. The only problem I saw with this approach is that it is a bit daunting to create seamless of maps for each foam mesh. Indeed, in Blender, when you want a ring circular mesh to have a seamless mapping, you need to perfectly align manually the map so that the image repeats itself without breaking the pattern. It's okay for a single asset, but for many unique islands and rocks in my game, it's more than I can handle. In addition, with cyclic seamless of mapping, if you need to tweak the wavelength afterwards, you cannot scale texture coordinates as you want. You are limited to integer multiples. I have to find something else. Process of scaling of map to get rid of the seam. Perfectly matching both sides of the seam can be quite long for many assets. Ideally, I aim at, as you know, my approach is far from perfect, and is only a compromise between what matters to me and what is technically reachable. To me, my first idea was to use automatic of coordinates, such as vertex world coordinates, which works pretty well for my procedural terrain mapping, which I might explain to one day, hopefully. However, world coordinates do not embed any kind of information about an hypothetical, privileged direction. This means I cannot have a classical foam texture with lines along the sharp edge like the one below, because it would be okay on some sides of an island, but not on the other sides. In this texture, there is a strong global direction, horizontal. The corresponding endgame look with world coordinates does not work. When I use automatic mapping, I must have some neutral uniform texture, direction-wise. For example, something like this, a simple foam texture with no main direction. The corresponding endgame look is a bit better. Okay, this is better, but it's still a bit stiff and disappointing. But that's the price to pay for an automatic method. Anyways, it does not seem to be enough to get visually interesting foam. Now, if I want some lines along the shore, are the foam moving towards or away from the shore, it is absolutely mandatory that I have an additional direction information embedded in the mesh. This is also necessary to make the foam vanish when it is far away from the shot. This specific direction changes for each rendered triangle, so I need to encapsulate it in a way another on the mesh vertices. Thus, I guess I still need to use a basic of mapping to specify this shot direction. To achieve this, I only need one texture coordinate, which I chose to set to V. See picture below. The idea is to have V0 on the outer edge loop of the foam, the C side, V1 on the middle edge loop of the foam, the ground side, and V2 for the edge loop that will be inside the island. The basic texture mapping. Here I do not really care about the same problem. You can see it at the bottom of the mesh. I only work on the V coordinate, so the movement towards or away from the shot will be built from this simple texture coordinate. The easiest way to create the famous foam lines is to use the sinus of V. To make it move, I offset it depending on the current time and the wave speed. Sinus, frequency speed time, clipped at 0. Keep in mind that, in order to get sharp edges, I clip any fragment value below a certain threshold. Changing the clipping threshold creates larger or smaller waves. Changing the frequency creates more or less waves. Now, if I want the sinus foam to wash away as it enters the sphere, I need to raise the sinus according to the V coordinate, like this. For example, sinus, frequency speed time, V, clipped at a good threshold T. Waves get thinner as they vanish in the sea. Now, let's have fun a little bit by adding noise to this initial shader. In order to make it more natural, as a noise-based texture, I use a simple RGB seamless noise texture that I made with GIMP using the solid noise generator. Seamless noise made with GIMP. From this, I can randomize the speed, the frequency while or any other parameter of the sinus. Randomizing the frequency is quite interesting. It is a way to locally add more or less wave lines like this. Adding world noise to frequency, sinus, frequency noise, V speed time, V, where X are the world horizontal coordinates. See how some zones get more foam lines, while other zones get fewer. The generated sinus part seems to work quite okay, but I think it still misses some connections between the foam lines, and to add them, I need to rely on world coordinates. I could use world noise to add these connections, but I wanted to try a more controlled approach by using a handmade texture on top of it, mixing the sinus procedural waves under the hand-painted texture. But if I use a pure binary texture for a foam connection on top of the generated sinus waves, I have no control at all on the vanishing of this texture. That's why I chose to use a distance transform texture. Distance transform images are created from a pure black or white base pattern. Each pixel of the distance transform image represents the distance to the nearest white pixel in the base pattern. Like this. Well, actually, I used an inverted distance transform here, because it's more convenient for the clipping phase. But you get the idea, and yes, I used a different pattern than the previous one. Distance transform images are just a way of seeing the data. You might also interpret it as a height map. Even if the meaning is slightly different, it might help to grasp the concept. The basic idea is to have an image that embeds some kind of evolution animation of the base pattern. Distance transform images may be generated through filters, but generally, these filters do not handle very well, or even not at all, seamless images. Another way is to paint some pseudo distance transform image directly. Of course, it will not be mathematically accurate. But as a benefit, we can create more custom animation patterns. An acceptable way I found is to use the unusual following settings in Krita. the paintings after a radius, which results in this. Directly painting a seamless distance transform texture. Notice the X pattern appearing on the intersection. This is typical of a distance transform image. Of course, this is a very mathematical way of approaching this idea. You can always drop with the default soft brush and get something totally okay, even more natural, I think. But you have to always keep in mind that you are painting an animation. Never thought I'd upload even that one day. Now, I have more control on the rendering of my hand-painted foam texture. Text A. Clicked at a certain threshold T. Now, I can control the width of the pattern by changing the clipping threshold for my hand-painted foam texture. Of course, I used a few tricks to make it more interesting. Text A noise speed time, text speed time, V. Clicked at T, and now, I can finally mix both the procedural sinus waves and my hand-drawn foam. After a few tweaks on threshold, speeds, noises, and other parameters, I ended up with this. The final result, mixing procedural and hand-drawn foam, ratioSinus, sinus, frequency noise, A, V speed time, V, ratioTex, text, A noise speed time, text speed time, V, clicked at T,